Hey, there's the big question. It's Mr. Peterson. That's the big question. Where does the matter of a plant come from? So if we watch this is a squash seed that's germinating. It's in some soil, right? But where does the matter, where do the atoms of that plant come from? Where are they coming from? It's kind of interesting to watch this. This is sped up quite a bit, but the question remains: where does the matter of that plant come from? So this is going to be one of three screencasts that are about matter. So kind of a trip down memory lane, I hope. So this first screencast is going to be about matter and the octet rule. All right, so you think about atoms and hydrogen and oxygen, really important atoms to us. And actually, there are about 118 different elements on the periodic table, but not all of them are part of living things. As a matter of fact, very few of those atoms wind up in living things. Oxygen and hydrogen for sure. Carbon, yeah, for sure. Sulfur, yep, important for proteins. Phosphorus, important for cardiac function and muscles. And nitrogen, really important as far as proteins go. So there's about 5 or 6 different elements that are really important of those 118 that make up living things. As a matter of fact, most of the atoms in your cells in living things all over the planet mostly are oxygen. Mostly oxygen. Oxygen and then carbon and then hydrogen and then nitrogen and a bunch of other stuff. So most of the atoms, if we count the atoms, we've got hydrogen, carbon, and oxygen make up almost all living things, living stuff, the matter of stuff. So a quick review, right? An atom. This is an oxygen atom, has an atomic number of 8, which means it has 8 protons. It also means it has 8 electrons. In this case, this oxygen isotope has 8 neutrons. So 8 protons have 8 positive charges, 8 electrons have 8 negative charges, and neutrons have no charge at all. Protons and neutrons in the center of the atomic model in this case, and that makes up the nucleus. And then the electrons are flying around the outside, and they're in different levels based on the amount of energy that they have, right? So hopefully you remember something like that. Now, we're going to talk about bonding here quickly, and it's all based on the octet rule, with the exception of hydrogen. So we'll start with hydrogen. Hydrogen doesn't have room for 8 electrons. It only has room for 2. Carbon, on the other hand, has room for 4 more. It has 2 in its inner valence shell, and it's 2 in its inner energy level, and 4 in its valence shell. Valence is the outer shell. Oxygen is missing a couple, and neon, if you remember, neon's all the way to the right of the periodic table, and it has 8 electrons. So it's kind of like this. Here's an ice cube tray. Some of you are like, what's an ice cube tray? So electrons fill the energy levels just like you fill ice cube trays. You have to fill the one at the top before the ones at the bottom can get some water. So in the case of atoms, we put 2 in the first energy level, then we put 8, and then it changes from there on out. You'll learn more about that in chemistry next year. Uh, in order to get to that full valence shell, that's when bonding happens. So let's look at hydrogen. Hydrogen is a pretty simple atom, right? One electron, and the bonding happens when 2 hydrogens get close enough together, and now they share a single electron. So now they think they have to. They don't think, right? They're just inanimate objects, but the behavior means that they're kind of pretty stable now because now they have 2 electrons. If we look at carbon and the way carbon reacts with other hydrogens to make methane, CH4, 1 carbon, 4 hydrogen atoms. Carbon needed 4, and it takes 4 single electrons from hydrogen to get there. And now we've shared those electrons. Carbon's valence shell is now at 8. What about water? So here's oxygen. Oxygen has 6. It needs 2 more. And hydrogen will provide that. So H2O has the sharing of 8 electrons. Oxygen's borrowing a couple from hydrogen to fill its outer shell. So that's the basics of bonding. We're going for that octet rule, trying to get to 8 electrons, and by sharing. So these are bonds between atoms. Hope that helps.